thank you for attending this fourth meetup of Swift on the server side. We have different members from the Swift server working group. Janice, you're in the Netherlands. Sven, you're in Germany. I hope I'm right.
France.
In France. Tim and Adam from UK, unless you're traveling also, Adam, today.
Welcome, everyone. We have an exciting agenda coming up. So we'll be talking about, we'll have Andrew Barba talking about infrastructure as Swift. Andrew is known from his work on Swift Cloud. And then we have Nathan Rolnick talking about Serverless Swift with Hummingbird and DynamoDB. Nathan also runs the Swift Dev Toolkit, which is a blog in the Swift server and tooling ecosystem space.
And we will finish like the 3 other meetup with Ask Us Anything, Amma, or Ask Me Anything from the team from the Swift Server Working Group. So Team Sven, Janice, and myself, Adam, if you are still there at the end, we will try to answer any questions you might have about Swift and Swift on the server. Since the last meetup 3, there is one notable change in the Swift community. Swift 6.1 has been released a few weeks ago. I don't have the date in mind, but it was just around the corner. A couple of syntax change, a couple of significant new capabilities as well. On the syntax level, I like this one. You are not obliged to pass the return value of a child task when you use with task group or withdrawing task group. The compiler can detect the correct type by itself. And I think one of the most controversial change in Swift 6.1, we were talking about that with Vernie just before. Some of them love it, some of them hate it, or you're in the middle. Tell us what you think. It's the trailing comma, which is now allowed in tuples, in parameter list, in generic parameter, string interpolation as well. I like it. I'm on the side of those that like it because you can easily comment your last value and without the need to rebalance the comma. The big thing in 6.1 was the introduction of tray. So tray is a new configuration for the ones that are creating package. It allows you to offer different types of API or feature for specific environment. For example, if you create a package that can work both for on Swift and WebAssembly, you can have you can define the dependency, and you can define you have a compilation conditional compilation, sorry, that was the word I was looking for. Conditional compilation inside your code to compile differently depending on the platform. And as a user of a package that offers tray, there is a new keywords in your package.swift that defines the tray that you want to enable for your project. So the example of the code on the screen, it's a client side of the tray. I didn't put code for the server side of the tray. And when you combine tray with Swift testing, you have no Swift testing tray. It allows you to perform logic to run before or after each of your run, like to have a shared setup or tear down logic. So you can write a custom tray type which conform to the test scoping protocol, as in the code example there. And there you can implement a method to customize the scope in which each test or suite the tray is applied to, or will where the tray will execute. So this is an example from the official announcement. I think I take that there, that shows you a trait which binds a task local value to a mocked resource. Coming ahead in a couple of weeks, we also have .DC, Janice.
Yeah, so WWDC, there will be a couple of us from the working group there as well. And the Vapor community is hosting a meetup in the area as well. So feel free to check it out. If you're in the area, come visit us, have a chat.
And that's pretty much all for the updates on our site. Let's go to the core of this meetup with our two guests, Andrew and Nathan. We're going to start with Andrew. As usual, please leave your comments on the chat on YouTube, and we will report your comments, your feedback, your questions to Andrew at the end of his talk. So don't be shy. Ask your question. I'm going to read them and share them with Andrew after his talk. Andrew, up, the
Floor is
stage is
yours.
yours.
Oh, one sec. All righty. Hey, everyone. It's great to be here. Very, very excited about this. So yeah, today we're going to talk about how we actually deploy Swift to servers, right? Like there's so much tooling and great innovation happening with making Swift run on servers, but a common problem I see is how do you actually get it there? And that's what we're going to talk about today. So a little bit of background on me. I started building iOS apps around 2011. So this was when iOS 5 came out and automatic reference counting was added to Objective-C. And then I was a very early adopter of Swift. So using Swift, basically at 1.0 to ship apps to the App Store. I led the team at Barcel Sports, but I joined as an iOS developer, and then I ended up leaving as CTO. So between that time of joining as iOS developer and becoming CTO, much of my career switched to be more of a backend architect. So writing a ton of Go and TypeScript and Node and a lot of languages that are not Swift. And then 2 years ago, I joined Vercel to build their CDN Edge network, which is also a lot of Go. And then today, actually, their billing infrastructure team, which is largely TypeScript and Node. So yeah, in today's world, I write too much TypeScript and Go, but I really love Swift. I've spent a lot of time with Swift, and in my free time, I've been doing whatever I can to try and make Swift more approachable on the server instead of just iOS apps. So, common question: how do you actually deploy a website? If you're familiar with Vercel or a few other companies in the space, it's become very easy for web developers. You write your code, you git push. Vercel's platform will then go build your app for you, and then a few seconds or a minute later, your website is deployed. But how do you deploy Swift? We don't have those types of tools. And so that is what I'm going to show you today. So yeah, the agenda, I want to talk a little bit about server versus serverless. I think this is a really important concept. Of course, we're going to talk about infrastructure as code. And then I'm going to introduce an open source framework called Swift Cloud. And then I'm going to hopefully get through a full live demo without any hiccups. And then, of course, some questions. So yeah, let's talk servers versus serverless. This is a buzzword. I'm hoping people have heard this term, but maybe they don't totally understand what exactly this means. So first things first, we always deploy to a server. So serverless does not mean that servers are not involved. Of course, we create a Swift binary. That binary has to run somewhere. And of course, that somewhere is a server somewhere. So the difference here really, and where this came from, is how do you pay for these servers? And that's what has been very different between these two models. So in a server full world, you're basically just renting, right? You are renting CPU and memory at some fixed cost. You're saying I want 4 CPUs, 8 gigs of RAM, whatever it is, and you are paying for that, for the duration of the month or however long you use it. Serverless really changed this entire model. What serverless is doing is they're saying you're paying for consumption or features, where now you're being billed on things like requests or bandwidth or storage or some made up feature that they have that has a price model associated to it. So serverless it's a very different model. It creates a lot of complexities for the cloud providers to be able to offer something like serverless, and it has some really interesting side effects. My personal favorite is it allows for scale to zero. If you don't have any requests, if you're not sending any bandwidth, you get to pay $0. And that's a pretty amazing feature. There are downsides to this, of course, but it opens up a lot of interesting things. Okay, so infrastructure as code. So, you could go log into AWS and go click a bunch of buttons and try and upload your binaries and create the correct, configuration for your servers. But what we really want to do is we want to write code that defines our infrastructure. And this gives us a ton of consistency. Right now that we have code defining our infrastructure, we can eliminate drift between environments, right? Like we now have a repeatable way to deploy to different environments. It speeds up deployments. It's predictable. We can then run these things, over and over in something like GitHub Actions or another CI provider. It's now version controlled. So if you're changing your infrastructure, you can go, view a PR and see, what am I actually changing? Does this change make sense? Whereas, the button clicking, you lose all of that history. And then there's a real efficiency aspect to this as well. You're really cutting down on manual errors, misclicking, things like that. Also, a lot of these providers are going to help you with auto scaling to reduce downtime. And then, of course, just the human element is probably the most important. All right, so Swift Cloud. So what is Swift Cloud? Well, this image here is basically an infrastructure as code written in Swift. And so what we're doing here is we are defining a Lambda function, we're defining a queue, we are subscribing to that queue, we're defining a web server that can publish to that queue. And this is what I mean by infrastructure as code. We want to write Swift code that declares our infrastructure, and we want to make it as easy as possible to go and deploy that. So we are describing our infrastructure in Swift. It lives right alongside your code. So this isn't a separate repo. It's not like it's its own language like Terraform or Pulumi or anything else. We are straight up writing Swift to describe our code. And you'll notice there's things in here like target name, right? That's an actual Swift target. So we have access to your Swift code to be able to do this. We know what to build and what binaries to actually deploy. The other benefit here that's not obvious by the screenshot is that we're using cloud best practices. There's a lot of configuration behind these 4 constructs. You have to get all your permissions right. And all those things are just handled for you based on the cloud provider that you're deploying to, in this case, AWS. The other thing you're going to notice that there's no SSH, there's no Dockerfiles, you're not using Node.js. This really is just Swift. And I am going to give you a full live demo of what this actually looks like. All righty. All right, so I have VS Code open here, and I want to open up a website that you might have heard of. So there's this website called Are We Server Yet? I believe someone on this call built this website. And what I want to do is show you how to deploy this site to AWS. And so what I ended up doing is I just cloned the repo and I made a couple changes just to separate things out. So what we have here is a target called server, and this is a bare bones Hummingbird app. And so if we run Swift, we're on server. So, okay, so yeah, we started up a server on 8080. And so let's go switch to localhost. And you can see here that we have the exact same site spun up on localhost. And now what I want to do is we want to deploy this to AWS, right? Like, great, we're running locally, but how do we actually get this thing deployed? And so today what I want to do is actually deploy it to a Lambda function, which is a serverless compute model. And so all I did is I just created a second target called Lambda, and it is very similar to the first one. There's a little bit of different configuration for Lambda, but you can effectively see it's the exact same router with a static file middleware. And we want to deploy this to Swift Cloud. So the way we do this is we are just going to define another target. So I'm going to create a new folder. I like to call it infra. And we're going to put a file in here, which I like to call project.swift. This file doesn't actually matter the name, but I think it's useful to think about it in this way. And let's go and define that target. So one of the first things we need to do is let's grab the Swift Cloud SDK. And we're going to go from branch main, and I'll click save. And let's go make sure that this actually builds. So this should pull in the Swift Cloud SDK. And I do need the Swift tooling gods to cooperate today. That would be great. Okay, great. So that pulled in the SDK. And now we're going to go declare a new target. And this is just going to be called infra. So this is where we're going to define all of our infrastructure related to our app. So what we do is we vend this package called cloud. And this is how we're going to define our actual infrastructure. Let me just make sure this looks good. I believe Adam is on this. I hope he's holding his breath, making sure that all this VS Code works. I guess I didn't even mention that. So I'm not using Xcode. I haven't used Xcode to build server-side Swift apps for a very long time. I pretty much only use VS Code thanks to Adam's work. All right, come on here. I need this M4 Mac to speed up a bit. There we go. All right, so now let's go over to this project.swift file, and we're going to import cloud. And we have this construct called a project. So I'm going to create that and just say project. And in this case, we are deploying to AWS. So I'm going to go ahead and declare this as an AWS project. And you're going to see that we have some stubs that we have to implement. So let's add them. And there's only one of them. It's called build. And this is basically the function where we are going to describe all of our infrastructure. One other thing I'm going to do is I'm just going to give this project a name. This technically isn't required, but it is useful, which I'll show you in a bit. And inside of here, I want to declare our infrastructure. So I want to create a function, and it's an AWS function, or behind the scenes, this is a Lambda. Let's just call it my site. And this takes in a parameter called target name. So that target name is the thing that I have here. So I'm just going to call this Lambda. And we just reformat this. And then the next thing I want to do is I want to make this available on a URL. So by default, Lambdas are private. So I am going to just call enabled, and we don't need anything else here. And then let's return the function's URL. All righty. Okay, now let's do Swift build. I'm hoping this doesn't complain here. Great, so that built. So now what? Now we actually need to deploy. And in order to do that, we actually just run this target. So we're just going to call Swift run infra deploy. And this is baked into Swift Cloud. So this is a special command inside of Swift Cloud. And you'll see here, we have a nice little CLI app that spins up. And this is going to go ahead and build our actual target and deploy this to AWS. And again, as I mentioned before, the goal here is to avoid all the button clicking in the AWS console. There's also, if you're familiar with Lambda, you have to build this in a certain way. You need to use Docker to build this. All of that stuff is handled for you. So this is building for the correct environment. Obviously, I'm on Mac OS right now, but you would not be able to deploy, a Lambda or a Swift binary built on Mac OS to Lambda. So it is handling all those things for you. We can see here we're deploying, so we're updating some configuration. There was flashes of like AWS resources being built there. And there you go. So we're now deployed. So look, we just spit out this URL. So this is obviously an ugly URL, but if I open this, there you go. We now deployed a Lambda to AWS in literally just a few lines of code. And that is like really, this is like very much the tip of the iceberg. Like, we can go way beyond this, but I think like this experience alone is just such a game changer for putting your code on a server somewhere. And so now I want to actually take it a step further. Obviously this URL kind of sucks. So let's create let's actually put a CDN in front of this. And I work at Vercel. So we are going to put a Vercel CDN. in front of this. And the way we do that, so this is a special construct. There's a similar one for AWS, but we define our origins, and we're going to say that we have a URL, which is the function.url, and we just want to route everything. So we'll just put in the root path here, and then for the domain name, we have a really interesting way of doing this as well. We can say something like sssmdemo.vercel.app. And for the DNS provider, we have one built in called vercel.app. And let's return the CDN URL. And let's just go ahead and run deploy again. So you'll see it's going to rebuild. This build should be much faster because it doesn't have to do anything this time. Yeah, so you'll see the build was done pretty quick. And now you can see flashes of Vercel infrastructure being created. All right, and now we're done. And so now we actually have both URLs. So we have the Lambda URL, but then we also have this special vercel.app URL. Let's go ahead and open this up. And there you go. Now we have a really nice URL on top of vercel.app, and this is now full CDN in front of the Lambda function. But we can take this even further. Notice that, well, actually, let me just show you what my Vercel console looks like real quick. So if I go into here and refresh this, so this is what it created in Vercel. And you'll notice that this project is called SSM Demo CDN Main. And what's interesting about that is, so the SSM demo should make sense. It's called it CDN because I called it CDN here, but it got main from the Git branch. And so that should tell you something. So what we can actually do here is we can easily deploy a second environment. Let's just call it dev. And let's say we want to change configuration based on the environment. We can do that too. We have something here called context stage. And let's just say if this is equal to main, then we want this URL. But if it's not equal to main, let's do another URL. That's JavaScript, sorry. And let's call this dev. Let's just reformat this. And now let's actually deploy the dev stage. What did I mess up here? And so now we're deploying to a brand new stage. And so what's going to end up happening here is you're getting a brand new function, right? So now you actually have functions per stage. We could have environment variables in this function that are completely different, and you're basically getting completely isolated infrastructure here just by deploying to a new stage. And so now we have dev and prod. We barely had to change a thing. All you have to do is rerun deploy. And so this makes it really easy to split up your infrastructure. I hope I'm doing okay on time. I kind of lost track. Alrighty, cool. So now we have a second function. We have this URL. So let's open this one up. And there you go. So now this loads on the dev domain. And if we were to go back and actually look at my Vercel projects, what you're going to see here is, so now I have one for dev and now I have one for main. Yeah, that's it. So yeah, that's the demo that I wanted to do today. Let's go back into Keynote. And let's go back here. Yeah, so like I said, this is really just the tip of the iceberg. You can take this way further. You can build distributed systems, things like a web server talking to a queue and then processing messages off that queue, but on a Lambda. Schedule jobs like cron jobs are trivial. We have full support for databases, so you could spin up Postgres, MySQL, Redis, Dynamo. and of course storage. So it's trivial to spin up, S3 buckets, for example, and get all the permission right between them. And then as I showed here, this is really multi-cloud. You can link cloud providers together. So I have support for Vercel, Fastly, Cloudflare, AWS, and DigitalOcean. You can take advantage of all of them. Definitely AWS I have the most support for, but I have constructs for all the other cloud providers too. And yeah, thank you so much. So yeah, it's all open source. If you just go to swift.cloud, you can try all of this. My docs are a little bit lacking, but yeah, I mean, would love feedback and would love for people to give this a try. Yeah, thank you so much.
It was very impressive. Nice to see that, Andrew.
Thank you.
Very impressive. Wow. I want to try that. Maybe I can start because I have the microphone with the first question. Are you using the cloud API behind the scene to call and to create the different infrastructure, or are you transpiling to Pulumi, Terraform, or something else?
Yeah, it's a great question. So it is compiling to Pulumi. I think I'm still sharing my screen here. So we can peek behind the curtains a bit here about what's going on. So you'll notice that there's this cloud directory, and you can open this up, and there's a few things going on in here. But effectively what happens is this build function is just producing a YAML file. So, and this is real Swift code, right? This is an async function. You can go, you could fetch blog posts in here. You can do whatever you want, right? This is just Swift. But at the end of this build function, the result is a YAML file, and that looks like this, or JSON in this case. And so this YAML file is describing all of your infrastructure. Right. So what we're saying here is that we have a deployment. It has these properties. We have a project domain. We have, all these things, policies and roles, and all the things that you would never, want to understand yourself. But ultimately, this document is created, and this is passed off to Pulumi, which is actually just Terraform, and that is what's creating all the things behind the scenes. So yeah, really the magic of the SDK is obviously strongly typing these things in Swift. But the other real magic is Pulumi doesn't help you make the best decisions. Their defaults, like there are no defaults. So getting the defaults right, to have a function in 3 lines of code, that is really what the SDK is doing for you.
Excellent. We have a couple of questions on YouTube as well. Because of the technical problem at the beginning, I cannot put them on the screen like I did the other time, so I have to read them aloud. We have a question from Ryan asking how the SDK know which AWS account to deploy if you don't use it in the default profile. And is there a way to set the profile from within your Swift code?
Yeah, there is. So yeah, so I have it. So there's an env file here. So something I didn't, I'm not going to open it because it will show my environment variables. But in this env file, like I had a Vercel API key set here. So that's how I was able to deploy to Vercel, for example, is that API key was set. And then for AWS, I like to use this app called Leap. So you'll see I have access to all these AWS accounts. So I had the AWS CLI configured for my Swift Cloud account. And so it's using the default, but the AWS SDKs and Soto in this case, they have a whole chain of logic for how they pick which account to select. So we do have support for like the AWS profile environment variable and whatever. There's like a whole like list of things that it checks to see which account, and that's all supported out of the box.
What is this application that you have there on the screen? Leap? I don't know.
Yeah, this is called Leap. It just makes it really easy to sign into different AWS accounts. And what it ends up doing is it sets like your local AWS credentials. So, like I could really quickly switch to like a Vercel account or whatever it might be. So yeah, I just had it connected to my Swift Cloud account for now.
Okay. The first time I see this application, it's public, it's downloadable from somewhere.
Yeah, it's open. It's open source too.
Okay. Cool. Leap. Next question from Alexander. Is there any benefit of defining infrastructure in Swift instead of Terraform, for example? Maybe better code reuse. Why should I write? Why should I write in Swift?
Yeah. So, well, first of all, I think we want to be Swift developers. So I think it's the more we use Swift, the better. So I think that's the obvious part. But something else that I didn't I didn't show off in here is there's a runtime SDK inside of Swift Cloud as well. So if we open up package.swift, and we could actually add a dependency. So to the Lambda, for example, there's another package in here actually called Cloud SDK. And let's call it build. And let's see if this actually works right off the bat. Well, actually, yeah, it might be hard to show in the time allotment. But if I open
Okay.
up the actual Lambda here, you would be able to import Cloud SDK, and this has some neat things on it. So if you were to do cloud SDK.cloud.resource, when you build your app, all those resources will be exposed here. So let's say you hooked up a queue, for example. You now have fully typed access to that queue in the runtime, right? So now you can post to the proper queue. You can post to the right S3 bucket, things like that. So yeah, there is benefit of actually, you know, it's just a Swift target, right? So you have full code sharing between the two, and then you also have fully typed access to all the resources that are created.
Yeah, just the fact to have strong typing, it's a lifesaver in many cases as well. Another
Exactly.
question from Gantiplex. Is it a question or is it a comment? It says all of the storage, all of the storage and the like is configurable as well. It's sweet. Looking forward serving stuff from open source LLM, looking like an alternative to on-device LLM. Yeah, I'm not sure I understand the question. Let's go to the next one. Philip asked if it works with any CI chain. Have you tried to integrate this inside your CI chain?
Yeah, it works. I mean, it works great in GitHub Actions. That's the only one I've tested in, just because I'm a heavy GitHub Actions user. I think I'm trying to think if I have that actually hooked up anywhere. I thought I did. But yes, it definitely works well inside of GitHub Actions.
Inside
Yeah, I don't know.
GitHub, cool. Francesco Paolo is asking why you never release even a beta version. It's not even 1.0 right now.
Yeah, it's because the structure of the SDK has gone through a lot of transformations. There's a ton of trial and error to get it to this point. And I've you'll hear Nathan talk in a second. I've broken many things on him, so I didn't want to call it 1.0 until I can not break things. But yeah, I think the structure I have in the SDK now is, I think, pretty locked in. So you know, I basically have a folder for each cloud provider, and there's some consistent things between each provider. So I think we're close to a 1.0. I should probably add more tests, but yeah, it's mostly just because I kept breaking things.
Richard is saying, so now if I understand correctly, I can make a full server-side application with Swift and deploy on Vercel, on Cloudflare, and Jesse asked for Azure as well.
Yeah, I think Azure would be an obvious next one for me to do. That's probably the biggest one that I haven't looked at yet. But yeah, that would be very doable to support some Azure constructs as well.
I have one question. Yeah. So do you have any example projects that demonstrate how people can use this, that we can point them to?
Yeah, I'm working on one that I'm going to publish soon. That will be called Swift Cloud Demo. And I'm basically just creating a bunch of different demos in here. So I don't have a lot yet. But you know, you could see like a basic queue example, you know, how you create, you know, queue. So I'm basically just going to beef this up with a bunch more examples, and this will be public on GitHub, hopefully very soon.
Excellent. Looking forward to it.
Cool. Looks like we have no more questions. If you have still question coming while you're listening to the next talk, put them in. We'll continue to ask question to Andrew at the end of this talk. Let's switch subject a bit, but not too much, by the way, because we are still going to talk about deploying to the cloud and deploying serverless with you, Nathan. So you're muted. You can unmute. Yep, and send me your screen so I can share with the rest of the talk, the folks, and then the stage is yours.
Yeah. So hello everyone. Thanks Sebastian and Johannes for the invite. Thanks Andrew for your talk. All the content and SDK you created will really help here in my talk. I'm excited and honored to be here. We'll talk about serverless Swift using Hummingbird and DynamoDB. A quick intro about myself. So I'm an iOS tech lead at Monday.com. I started developing for the iPhone on iPhone OS 3, learned to program in Objective-C. And I also have a passion for web, server, and tooling technologies, which is the subject that I post weekly on my website, swifttoolkit.dev. So what are we going to cover today? So we're going to start with a little intro about Hummingbird 2. And then we'll move on to why serverless. Andrew already covered a little bit. Then we'll go to DynamoDB, some basic concepts, running locally and accessing it. We'll have a sample project, a running tracker app, which will use Dynamo, and we'll add a Lambda executable target to it. And finally, we'll deploy with Swift Cloud. So by the end of the talk, we have deployed the Lambda function to AWS, built on top of Hummingbird 2 that writes and reads data from DynamoDB. So what is Hummingbird? It's basically a lightweight web framework in Swift. So imagine you have a server.swift file. You start by importing Hummingbird. You initialize your router, and then you add requests to it, get, post, put. You initialize an application with this router, and finally you run this service. You run the server, and Hummingbird will take care of routing and everything else. Under the Hummingbird project, you'll find multiple packages. So Hummingbird is extremely modular. So you can find, for example, a Hummingbird Postgres package, or if you used Fluent with Vapor, there is also a Hummingbird Fluent package. There's another package for dealing with authentication. If you want to use a cache with Redis, you can also use the Redis package. WebSocket support. And also there's a Hummingbird Lambda package, which we're going to soon dive into a little bit. But before we do that, before we focus on this one, why serverless, when it's a good option, and how it differs from a traditional server. Andrew already covered that a little bit, so I'll be a bit faster here. So you usually rent a server somewhere, and you're going to probably use Docker to deploy your application. And if you have some larger scale, or you want something more, not a hobby, you're going to probably have a load balancer on top of it that can really scale your server up whenever there's more need, and down whenever the load is a bit lower. So on these traditional servers, let's imagine throughout the day, the load and the capacity. So whenever the load goes up, your load balancer is gonna spin up new servers, and you can see that we have this orange line here that is server capacity or memory that's not used. And so in these cases you're over provisioned, but you might also happen that you are under provisioned. So maybe your servers are not starting fast enough, and the load is too high. So with serverless, that's a bit different. So it's the infrastructure provide the responsibility to spin them up, and you don't need to worry about choosing the server size, storage. You only choose a memory, and as Andrew said, you only pay for what you use. So it's infinitely scalable, and two, you are going to pay for the memory you specify times the consume time for functions. So back to the Hummingbird Lambda package. What's the responsibility of this package specifically? So as I showed before, you can run Hummingbird as a regular server. So if you want to adapt it to run into Lambda, what this package is going to do, it has two roles. So the first one, it's going to, you provide a responder to this package, as we saw on the implementation that Andrew showed us. So there is AWS Lambda. It's going to forward to you events, and the Hummingbird Lambda package is going to take that event, and inside your Swift executable, you provided the HTTP responder. So whenever new events, in this case, they are HTTP requests, whenever they come in, it forwards the requests to your responder. And once your responder provides a response, the Hummingbird handler is going to convert it to the expected Lambda output, which if you do manually, it's a bit more tricky. So, and the second responsibility of this package is it's going to translate the input. The input comes as an API gateway JSON, which contains keys, for example, headers, the HTTP method, the body, and it converts this into an object that you can actually use as a Hummingbird as a Swift object with regular properties. Now, moving on to Dynamo. So my first experience with databases was with Core Data around 13 years ago. As if you're talking about Swift, probably that's what many iOS developers did. And this is on top of Core Data runs mostly on top of SQLite, the backing store. And many other DBs are also SQLite based if you are using Swift Data, or if you're using GRDB on top of SQLite directly. And if you program server applications, probably you use Postgres or Fluent as an ORM on top of Postgres, for example. And they all have one thing in common. They're all SQL based. So they're relational databases. And their mental model is very straightforward. So for example, for each object you want to store, you define a different table in the same database. So if I want to store users, I create a table for users. If I want to store an activity, for example, the user went out and ran, so I create another table. And if I want to store media, for example, a video that the user uploaded, I'm going to also create a table for that. And I can start adding relationships to them and have joins to build this data together. So in a first moment, when you start working with Dynamo, you might go ahead and create a table for one specific model, and this way you might also do something similar to SQLite, which is using an ID using a single attribute, a column, as the ID, the identifier of the object. So this works in Dynamo. Okay, that, for example, I can have a table of users, and the username is going to be the identifier. I could use another one. So, for example, I can have different names, and I can have a property created at, which I convert to a string. I can have a longest run, which is a number, and I can also have, for example, a Boolean property. So this works with Dynamo. But this works pretty much like a key value database. And although it works, it's not the best way to use Dynamo. And why are we used to splitting things in tables? So basically, when the first relational databases first shipped in the late 70s, the constraint was mostly storage, wasn't computing, wasn't compute process power. So you store the minimum amount of data, you spread them in different tables, that represent these types, these models, and whenever you want to fetch them, you use more processing power when you need to fetch. So this is, in SQLite language, this is joins, they're joins. So you try to reduce the footprint of the data on disk. And this is fine for many scales, but once you have many tables or the data grows too much, it doesn't scale so well especially if you have multiple joins. And in the last 2 decades, this pretty much shifted. In the last two decades, nowadays storage is cheap, but compute is expensive. So a new type of database has emerged. They're called NoSQL. MongoDB is also a NoSQL one. So they are not considered relational in the traditional way of the word, even though you can build relations on them. And I'm going to soon explain a little bit what I mean by that. So once I started learning more about Dynamo, I heard a concept that's called single table design. And I was like, what does this even mean? Like, how can I have a single table at all? And the truth is that if you want to really learn and understand how it works, you need to forget anything that you've learned before about relational databases. And once it clicks, it's fascinating. Personally, for me, for example, when I started understanding how Swift UI really works, in comparison with UIKit, I was like mind blown, and that's how I felt when I started understanding DynamoDB. So yeah, it was like, wow, it's a game changer. So how do you enable this? How do you enable this single table design? To enable single table design, you are going to use a composite primary key. What is a composite primary key? So the ID is made up of 2 columns now. They're not 1 column anymore. So the first one is a partition key. Partition key is where DynamoDB is going to decide where the item will host physically inside the database. And the second one is a sort key. The sort key is used by Dynamo to know, let's say, when you fetch objects with the same partition key, Dynamo is going to know how to sort them correctly. So a bit of a practical example. So imagine now that we want to store activities for users. We can have all of that in the same table. So now I call the partition key PK. You can call them anything. I just call here PK because it can be more than one thing. And the same with the sort key, I call that SK. And together, these two, they form the primary key. So imagine I want to store now profiles. I can call the partition key, let's say Nathan Roenick or Andrew Barba, and the SK, the sort key, is going to be profile. And for these objects, I'm going to have, for example, confirmed email and created at. Now, the cool thing is that you can do something like this. So you can have other objects, and they are the partition key is the same, but the sort key now has another format. So for example, it has run, £, and the date as a string. And for these ones, you can have totally different properties. And you can see that they also have different types. And I do not need to fill these columns there are no columns in fact, but I don't need to fill these properties for these other objects. So another concept in DynamoDB that you might hear a lot is access patterns. We're going to soon explain what access patterns are, but there's a little limitation of DynamoDB or NoSQL at all. Is that you need to know beforehand how you're going to access your data. And with that, you need to plan how to model the database. So what access pattern means? It means that your query patterns are going to dictate how your models are going to look like in the table. So, and this is very important because you might eventually need to do migrations after that. So plan ahead really well how we're going to fetch, how we're going to query your data, and only then go ahead and start modeling. And another thing that is also important to understand is that queries, they are very different than scanning. So in SQL language, the queries are just regular queries. In Dynamo, they're quite different, and I'm going to explain here. So queries, they're tied to the primary index. They are faster, more efficient. They're much cheaper. You should never use scans. So the query is based on the partition key and the sort key. As I said, these together form the primary key. And so, for example, I want to get an object that the primary key is Nathan Roenick, and the sort key is profile. Or, for example, I want to get all the runs for Andrew. So I can do the primary key is Andrew Barba, and the SK, the sort key, begins with run #. So this is going to know how to give me exactly what I want. So a query is basically using a tweezer. You know exactly what you wanna get, and this is what you should use almost always, if possible. You should never use scans. So scans, it scans your whole table, and then if you have filter operations, which, for example, in SQL you're used to do filter, the filter in SQL goes into the query. In scans on DynamoDB, it first gets all the objects, and only then it filters. So, and you also can use filters on any property. But the scan is much more like a tractor. So you should avoid as much as possible never using scans unless you have really small tables, because on Dynamo, we're going to soon talk about this a little bit more, but Dynamo is also serverless. So you pay for consumption, you pay for read units and write units. So the more you read, even though you don't get that data returned, you are paying for that. So why Dynamo is serverless? So take, for example, Postgres. You might start with a DB server, a small one. So you choose a size. Maybe you need something larger. You need a larger database server, or maybe you need an even larger scale. Then you're going to have a replica. So with DynamoDB, it's nothing like this. So first, it's an HTTP-based API. You communicate with it via HTTP calls. Again, it's serverless. You don't need to worry about infrastructure. That's AWS problem. There's no open connection that your server keeps connected to it. So you just access data as needed. And again, you pay for read and write units. It's super aligned with values of serverless. It scales according to your needs. You pay just for what you use. And yeah, you don't need to manage servers at all. Now we are going to move to the sample project. Just before moving there, I want to, for developing locally, you can run locally DynamoDB. So this, for example, is a Docker Compose file, which is found on the AWS reference. It uses the DynamoDB local image, and you can also uses a volume, so you can see also the data. And that's actually funny because this is not real DynamoDB. That's a simulation of DynamoDB on top of SQLite, but it responds to all HTTP calls that you would expect. So it's nice for developing locally. It has a one-to-one HTTP API with the real DynamoDB that runs on AWS. So if you want to run locally, you get this Docker Compose, and you run Docker Compose up. And you can also download the NoSQL Workbench app by Amazon, and you can start seeing your data there, querying, scanning. And for the sample app, a quick introduction. I'm going to do things a bit different than what I showed before. So, for example, I'm going to have user and #, the ID as the primary key. So, for example, I'm going to have user # ID1 or ID2, and the profile. I'm also going to use the profile sort key, and I'm going to have the properties there for the profile. And for the sort key, I'm going to use a run and the ID, but still they're going to, the primary key, they are going to be associated to the same user. And I can have also these different run properties. So now let's go a little bit to Xcode. So I'm going to show here the sample project. I have a Hummingbird app. I have a server. You can see that this is that's my target, and I depend on Hummingbird and Soto DynamoDB. That's the Soto package for interacting with DynamoDB. And you can see that I have my server initialization here, and I'm passing here Dynamo endpoint. This is very important. So Soto is going to know where to point to. It's going to point to the local DynamoDB and not to the real one. I have this configure function here declared. So if I don't pass anything, it's gonna talk to the real DynamoDB, and I also have to pass a table. And I already created beforehand. I have here, that's the NoSQL Workbench app. I'm gonna connect to my local Dynamo, and you can see that I have the running tracker table, which right now it's empty. So I initialize my application with the router. I give it a name, and I run it. So in my configuration here, I have two controllers. One is for users, and one is for the activities themselves. And you can also see I have the models. So for example, the user, that's the PK property, and user # the ID and the profile. You can also see that it's codable. So Soto is going to convert this automatically into the expected format that DynamoDB expects. And also here, we have the same callable. And again, notice how the primary key of them, if I use the user ID here, so Dynamo is going to know how to associate all of these different objects to the same user. And I already have, let's run this locally. So I prepared a few functions before. So for example, you can create a new user, get a new user, or get runs for this user. So the server started here. I'm gonna switch to the Rapid API HTTP client. So I'm gonna create a user called Nathan Ronick, and I'm gonna create another one for Tim. You can see that I have this user. So now I can get a user by ID. These functions, these are working. And I can also add runs for Tim. I'm gonna create, these are handled by, there's a runs controller, and I use this function to create them. So you can see this, I'm gonna post this as a research for the talk, but basically you can see that I decode the data from the request. I create a run activity with that data, and I do the put item operation, and I store it to Dynamo, and that's it. Now, if I want to get all the runs for Tim, I'm getting an error. It's not implemented one, and that's what we're going to implement here. So I'm going to stop the server, and if I go to the user's controller, you can see the error. That's the list runs call that we use on the get ID. That's the ID of the user, and the runs that we're going to return. So first thing, I need to get the ID from the request. To do this, I get the context from the request, parameters, and require an ID. If no ID is present, then it's going to throw an error. Now, the second thing I'm going to do is I need to create the query itself. So to create the query, I'm going to do this expression that PK, the primary key, is going to be this, the the user #, the user ID. And that's another important part, which the sort key is going to start with run. So it's going to give me all the runs for a given user. And I also need to use the table name. In all operations you do with against Dynamo, you need to pass a table name. And finally, I'm going to run this. I'm going to run this query. So I'm going to do dynamo.query, and this is a nice extension method that it's present on DynamoDB plus Scalable that gives me I can pass a type, and it's going to take care of converting them. And now I'm going to do, I'm going to do return to these items. Otherwise, it's an empty array. Now, if I run this and we go back to here, now we see one run. Let's create another one for Tim. So this is in seconds. So let's say he did a shorter one, and 4,000 it created. And if we query this now we get 2 items. These are the 2 runs that we just created. Another important thing here, you can see that I return sk and pk in the JSON. Probably you want to have some other type that doesn't expose this internal implementation, so you convert them to a public type. Okay, moving on. So the title of the talk is Serverless Swift. So how we're going to convert this thing that's running locally into a Lambda target that I can deploy. So right now, we have only one executable running locally. It contains the server initialization, the configuration, and the routes. What I want to do now is and Hummingbird allows me to do this in a straightforward way. I can separate the server initialization to an executable target, and I'm going to put the configuration and the routes into another target. So, and the server is going to depend on this, and I'm going to create a new target, which is going to be the Lambda target that imports the Hummingbird Lambda package. So back to Xcode. Now I already have a sample the sample project in the final state. So you can see that all the app logic, I converted it to a package, to a target called app. It's not an executable target anymore, but and you can see that we have the same controllers we have here, and the models and the configuration, the same configure method. And so you can also see that we have a server, and the initialization we perform here. And we have a new target called Lambda that I declared here. And this executable target, it relies on the app, depends on the app, and depends on Hummingbird Lambda and AWS Lambda events packages. And as I showed before, we create a router. This error, it's only on Xcode, don't have to worry about it. So I initialize a router. I use the same configuration, the same configure method that lives now in the shared package, in the shared target. And notice how here I don't pass a Dynamo endpoint because that's the default endpoint. And the table name, I get this from Swift Cloud. As Andrew showed in the end of his talk, one of the advantages of using Swift Cloud is that it gives you the typed resources to your application. Right now, Xcode's not finding it, but if I run Swift build from Swift run from the command line, it's going to find it. So that's the responder you return. I do return router.build responder. And yeah, and let's go back to the presentation. So now I want to deploy it with Swift Cloud. What do I need to do? as Andrew showed, you create a new target called the infra that depends on Swift Cloud. You import cloud or cloud. In this case, I'm going to deploy to AWS. I declare an infra type that conforms to the AWS project protocol. I declare a build function. I initialize my Lambda, as Andrew did. I need to enable the URL so I can access it via URL. I create a DynamoDB resource, a DynamoDB table, giving a name and the primary index. I need to give permissions to my Lambda to access this DynamoDB, so I link them, and I finally return the Lambda URL and the DynamoDB table name. So back to Xcode. So we have here the infra target. It's exactly what I just showed on Keynote, but with the names. And you can see that here I define my part. So you can see primary index. Primary index is the composition of these two. You could also, if you are doing only primary key, only partition key without sort key, this also works. But for the single table design, we are going to use a combination of both. I initialize my Lambda. I'm using 1024 megabytes. You might need to figure out what size works, what memory size works better for you. I link them and I return. So before the talk started, I already ran Swift run infra deploy, and I passed the stage prod, and it printed out these two outputs. That's exactly the two outputs that we declared here. So that's my Lambda URL and my DynamoDB table. I can take this URL now and take it into the client here, and I'm going to use now Lambda. And I just want to show quickly also on Amazon. I ran it before on a dev stage, and I also have my prod stage. So Swift Cloud is going to create all the resources that I need for both environments. You can also see that my table is empty. I could be using the NoSQL Workbench app. You can also use that app for inspecting your data remotely, but you can also do it here, explore items in the console. And now, so I switched from local to Lambda. You can see that this is the same. You have here the same URL as the one here. Now I can create a new user. So I'm going to create a user for Sven. And it worked. And I have the user for Sven. I can get Sven here. I can add activities to Sven. And I can also get his runs. Yep. And if you go now to the AWS console and I scan again, actually I can do both scans and queries. So I'm going to run a scan so you can see that it returns all items. So now I'm going to do a query. This you can do in the code as well, but I'm going to do, let's go back to the Rapid client. I can see here that this is the ID for Sven. So if I can get all the items associated with him. But if I want only runs, I can do begins with run #, and I get only the runs. In this case, run, but I would get all the runs. And I can also do, for example, profile. So you can do this all from Swift code via Soto. I'm just showing here how the single table design also works from how we can inspect the properties and play with them on the console. Now, wrapping up what we learned today. First, we saw how I can run a Hummingbird server locally. We saw what is DynamoDB, NoSQL, basic concepts, single table design. We learn how to split a Hummingbird app to allow running both locally and deploying to a Lambda. We saw how to initialize a Lambda function with Hummingbird and building the responder. And we finished with Swift Cloud. Everything that I spoke here, including links and the sample project, they are in this repository on GitHub. So feel free to access that and see. I've also posted their documentation on Hummingbird, links to documentation on Hummingbird, and also more links to DynamoDB, and 2 great talks. There are 2 excellent talks from AWS re:Invent, which you can find there on the links. And that's it. Thank you so much. Hope you enjoyed.
Thank you for the talk. Your microphone is muted.
A rookie mistake. That was super impressive to see it end to end, to see the Swift Cloud code, the Lambda code, the DynamoDB code, and all put together into an application. We have a few questions for you. If I switch screen and find a question, there was a couple of questions about the way you query DynamoDB and the cost in terms of latency to query very large table. If you have one large table with all your data, how does that affect the performance of the query? That was a question from Philip.
Okay, Philip. So Seb, if you just could mute while I reply. So that also was something that I asked myself in the beginning. Then so remember when I explained partition keys? So because Dynamo works with partition keys, that by design that's built for very fast query times, and this is very surprising, but DynamoDB has single digit latency time. So you have like queries that take 9 milliseconds or times like this, because it doesn't depend on the amount of data. Because imagine in the same way that you have, for example, an array and a dictionary, and on a dictionary you use a dictionary uses the hash to know how to access the items on a O1. DynamoDB uses something similar. So the partition key nowadays, it's called partition key, but before it used to be called hash key. The hash key, because DynamoDB makes a hash out of that and stores all the items with the same partition key in the same area. And with that, it can fetch really quickly all your items. And if you have conditions on the sort key, it's much faster than accessing the whole table. So that's how DynamoDB knows how to fetch to give impressive results with very, very fast. In the talks that I linked in the repository, they mentioned this to a deeper extent.
Yeah, there is just the full table scan, which might take a lot of time, of course.
Exactly. So that's why you should never use scans unless you have a little like a super small table, or if you need to export everything, so you use a scan, but you should, like, last resort, or not even that.
And there is a cost for a gigabyte of data being scanned as well. So be careful. Exactly. If your table is really large, a full table scan can cost you a lot of money. There is another question from Ryan about a Lambda function, where Ryan asked if you can reiterate on why to use Hummingbird on Lambda versus raw Swift code on Lambda with
right. So what is maybe I'll try to answer, and Ioannis, if you think you can add a little bit, go ahead. Sure. So you can have if you have a simple Lambda with 1-2 functions, then you're probably good. You don't need Hummingbird. But if for example, you get all the routing for free when you use Hummingbird, that's one thing. You probably wanna use the authentication that Hummingbird provides, so you might wanna use that on top, so you don't need to do these things manually. Nothing stops you from implementing this by yourself, but from the moment you have some application with different controllers and different routes, and that's quite hard to do it manually, and so you can just leverage Hummingbird. Johannes, feel free to complement.
Yeah, and the other reason that we created Hummingbird Lambda is because it allows you to switch between the two modes very easily, like you saw in the demo. So if you have, I personally have tried to use SemLocal for developing my Lambda Swift-based Lambdas, but it's just a lot more tedious to build your application using SemLocal. It's really hard to debug as well that way. So the development cycle just becomes that much longer when you need to spin up a local Lambda to test against. And it also allows you, if you need to migrate away from AWS Lambda to a different, like a container-based service if you need to. So AWS Lambda has some limitations in how it executes, and it's optimal for some use cases in terms of cost, but it's less optimal for other use cases or workloads. If you find that your workloads are not suitable for AWS Lambda anymore, let's say you have a background task that needs to run always, then a container might be better suited for your use case, but then you want to convert into a regular container-based service with its own web server. At that point, it's very nice that you've been using Hummingbird already, because you can just flip the switch and use a built-in HTTP server and continue from there with minor changes to your code.
Have you tried, I understand all the benefits, I fully agree with that. It's a question for you, Janice. Have you tried to benchmark the additional processing time added by Hummingbird when you put Hummingbird inside a Lambda versus a raw Lambda? I mean, is performance or cost can be a decision factor? Or should we really think in terms of portability? What Hummingbird offered is the ability to deploy on a virtual machine, on a container, or on Lambda.
I've not benchmarked the difference between Hummingbird Lambda and the raw Lambda runtime.
It's probably very low.
But it's probably very low because we only convert into Swift HTTP types.
Yeah.
Which also definitely already needs to happen to a degree. And the Swift Neo-based networking I/O that already happens in the HTTP server from Hummingbird also has overhead, right? I personally, just a guesstimate, right? My estimate is that the Lambda runtime will be faster than the Swift Neo stack with all the I/O operations working behind the scenes. So I expect the Lambda to be faster than what you see on a regular Hummingbird server. But that's just based on an estimate.
There is so Ryan says thank you for your answer, Nathan and Janice. Philip says, by your experience, Nathan, how can we reuse code for an iOS app and speed up the full stack development lifecycle?
That's a little tricky question because I'd say at least for database you shouldn't have any. You shouldn't access your DB obviously from an iOS client. What I think that can be very useful here is if you have all your models that you use to transfer data, both the requests, both what is expected in the request input and the response output. This you can have all of them in a separate package, and you can share this model, so there's no errors between what the server expects and what your app is gonna send, and the same way on the other way around, when you are decoding data, you are gonna be sure that you have the compiler playing on your side on both ways. When you send data and when you receive data, when you encode and when you decode it on both ends of the stack. So so code sharing for models is the first thing that I can imagine.
And it was actually the follow-up message from Felipe just after, just below the original message. He says, maybe sharing models. So yes.
Yeah. So that's what I would begin with. And if you have maybe another thing that it's also useful, and I don't remember 100%, if Hummingbird has support for it, is the I just forgot the name, that Apple released a while ago.
API generator?
The Swagger, yeah, the API generator, correct. And so
yeah, Hummingbird does have support for Open API generator.
Yes, so if you have Open API specs, you can also get for free all the endpoints and exactly what you should send and receive from consumers of the API and for the server itself. So that's, I think, the other level beyond sharing models is sharing also the specifications for the APIs.
Yeah, I also like Open API generator because there are tools that validate that you don't make breaking changes, and it all plugs into the existing ecosystem wherever you go. So if it's Vapor or Hummingbird, whether it's Hummingbird on Lambda or a raw web server, it will just work.
And Andrew, you comment back. Maybe I can put you back on screen. That will be easier. You comment back on the Lambda thing about the time to the first byte.
Yeah. So yeah, Lambda's architecture is it's pretty unique. So what actually happens is your Lambda function is actually polling a server to say, give me an HTTP request. So it's a very strange model compared to your typical container, which is just you have you listen on a port and messages come to you. So there's more overhead to Lambda than there would be on just having a container that's exposed to port 80, right? But I think the benefits of Lambda just like greatly outweigh those like small latency penalties. I didn't really get to show it off, but you start deploying, like, let's say you wanted to deploy for every single Git branch, right? Every Git branch you want to deploy, a stack so you can test it before you merge it. That's $0 on Lambda, which is amazing, right? If you were to do that with a container, you're spending a ton of money to keep spinning up containers. So there's a lot of benefits there, outside of just like latency.
I brought Sven on stage as well. Sven is part of the Swift Server working group as well. Thank you, Nathan and Andrew, for your talk. That was super inspiring. I know what I want to do tomorrow and start.
Yeah, thanks so much for having us.
To try that.
Thank you. Thanks for the opportunity.
For those of you that are still watching, any question about Swift on the server in general that Johnny's team, Sven, or myself can try to answer. There are still a few comments coming about Open API generated models that can share between the server and the client, as you mentioned, Johnny's. Yeah. And saying that the combo Open API plus a Swift backend plus a Swift frontend can be really, really powerful, and plugging the CloudKit into that, it's really end-to-end. That's a comment from Philippe. Yona says, amazing talk, Nathan.
Thank you.
I see a question not in the main. We have actually two videos being streamed right now because of a mistake. And in the other stream, someone asked, has there been a 2025 roadmap for the Swift Server Workgroup that has been posted or shared? Now, I believe we do have a roadmap, but I'm not sure if it's shared yet. Do you know, Sebastian?
I think it's still blocked in a draft status somewhere, but we will post that on the forum. I'll check the status and verify. I think it's ready to be posted, but it has not been posted.
Yeah.
I'm searching for the link for the forum, so I can share that on YouTube as well.
Yeah.
So it's here. So the 2025 roadmap will be posted there. The idea is to create more marketing, like to talk about Swift on the server through a blog post, through these meetups. There was a bit of work around some libraries, Janice, as well.
Can you repeat that?
We plan to further work on some server-side libraries as well.
Yeah, there are a couple libraries that are getting some major improvements. I can't share too much about it just yet, but there is something brewing. We are obviously looking to engage more with the community and see how we can work together on various libraries, but also on content is a major pillar for us the coming time again. I've been working with the Swift infrastructure project, infrastructure website architecture. So we're looking to see if we can post more content on swift.org maybe, or expose more information about various tools and techniques through other means on swift.org, improve the documentation.
There is a question from Michaeli. When is the next meetup? Excellent question, Michaeli. Thank you. When do you think we should have a next meetup? So we are almost in May. So we have two options. Probably it's at the beginning of the summer, end of June, beginning of July, or at the end of the summer, like August, September. That's my mental model for it. But please leave us feedback. Leave message on the Slack. Leave message on the forum. We'd love to know your feedback about these meetups. If you have ideas of subjects to share, either that you want to present yourself, or if you want to hear about one of our experts talking about different subjects, please let us know.
If there are certain talks that you're interested in hearing, or like specific topics you want to learn more about, definitely tell us.
There is a question from Yona about what are the benefits of Swift on server over TypeScript. Who goes for that? Janice? Sven?
Sven, do you want to take it?
Yeah, sure. I mean, I've never used TypeScript, so this is I'll say that out of the gate. But I've used Python on the server, and I think one of the biggest advantages is type safety. Like you build the thing, and it typically runs. You don't have I have way fewer runtime issues. Not sure how memory works with TypeScript and JavaScript, but that was also a huge difference as opposed to Python. It's just the Swift binaries running on the server are they do so little memory. It's just amazing. Like the size of your containers is much smaller. You need way smaller hardware to run the thing. Like in general, runtime performance is fantastic, and the development experience, despite what all people say about type checking, it really, in my experience, it really helps. You pay a bit of a price in compile times, but you get that time back, I find. Like I debug way less in Swift than I did in Python. And I think that's really significant, because I think that's time better spent up front. Let the compiler do the stuff, and you might wait a bit. But I find there's much less need to spend time debugging stuff. Obviously, it still happens, but I can't stress enough how liberating it is to have fewer runtime issues as opposed to upfront compile time issues. That's a price I'll happily pay every time, because you're much further away from when you actually make the mistake, right? If the compiler complains, it's about stuff you've just done. If something fails in production, like you're miles away, you have to start figuring out, well, what change was it? When was it deployed? What's the delta? It's really a significant advantage in my experience.
Yeah, I've had very few runtime issues over the years myself as well. Yeah.
Tim, you're not on camera, but I think you're in, and you have a lot to say about TypeScript.
Can you hear me?
Yeah.
Oh, no, sorry, I'm out and about, so I'll have to join
from the street.
My phone. Yeah. So I'm using TypeScript professionally at the moment, so in production on that project. And as far as languages go, it's pretty awful. It's very easy to break out of the type system and lose the types if you're jumping between functions and stuff. So you don't actually have a real type system, which can be really confusing when you're trying to work out why you're getting errors, because it's fine. And then when you actually use it, it doesn't work. And one of the other benefits I've seen is running lambdas locally is far harder with TypeScript than it is with Swift. Because with the Swift Lambda SDK, you can run a local instance, you can debug it, and you can set breakpoints. That's really, really difficult with TypeScript and JavaScript. So yeah, those are my two things I'd like to add in. And what Sven said as well, having a real type checker that catches errors is great.
Yeah, we have comments from Jesse on the chat that says that that's why I'm such a big fan of Swift. Low memory usage, great performance, still being usable and providing amazing language feature. And they use Swift on embedded Linux SBC, single board computer, an ARM v7. And it's worked really well for them. I continue to read a question on YouTube. A question from Craig. Any official effort in supporting Swift on FreeBSD? That's actually a question for Apple team. It's Apple managing the different release. It's not for our team, so I cannot really comment on that. Janice or Sven, if you want to add something.
I have heard a lot of rumors, not more than rumors. I've heard a lot of interest being expressed about Swift on FreeBSD, not just from outsiders, but also within Apple about supporting that. But I'm not sure what the status of that is or if it will land. But they are very much aware of it. Who knows? We'll hear about it shortly. I'm not sure.
There's a whole platform steering group. Sorry, there's a whole platform steering group that's responsible for porting Swift to other platforms. It's made up of Apple and outside people, so that's the best place to ask questions.
Yep, they would be the best.
Question from Shai. When the Lambda, so we are going back to your subject, Nathan. When the Lambda are sleeping, when they are not executing, do we pay only for storage? How does it work with cold, hot start? If the Lambda wasn't recently hit, is there a delay in startup? I can provide a short answer, but I'll let you complement with your experience. No, you're not paying for storage. With Lambda, you pay essentially two metrics. One of them is the number of invocation. I think out of memory, it's 40 cents per million of invocation, and the first million is free every month. And then you pay per CPU time, so per millisecond of execution time. And as I wrote in the comment earlier, you can choose for memory, and the more memory you have, the bigger is the CPU, and the bigger is the CPU, the higher is the cost as well. Hence the importance of using efficient language such as Swift, where you can minimize the memory. If you read the comment, there was a discussion between Janice and me during your talk, Nathan. About the cold start, do you want to answer, Nathan?
Yeah, sure. So I'm gonna leave also in the comments link that Andrew sent to us. This is basically a graph that shows how much you need, how much time you need your Lambda is gonna take to run, depending on how much memory. So there's a sweet spot that you choose a specific amount of memory that the result of this multiplication of time and memory is the lowest one. So so back to the question, if the Lambda is not hit, you don't pay, it's not running. There is the cold start that is what usually takes a bit longer, and then there's if you have like the Lambdas are active and they are all responding, they don't go into sleep mode, and you don't have the cost of the cold start, because you pay as an executable. It takes a few milliseconds for the executable to launch and be available. I think that Andrew can add a little bit more based on also his experience at Vercel.
Yeah, I mean, on the billing side of things, you truly do not pay anything if your code's not running, which is amazing. There's a built-in allotment of like storage that you get per account, but it's quite high. and that's just for like your your zip files that you basically upload. But yeah, if your code's not running, they don't charge you a thing, and their free tier includes something like 1 million requests a month. So it's you can get very far on Lambda without paying a penny.
Thank you for your answer. I'm trying to unpile the question. Is there any work on libraries such as ActivityPub and the AT protocol from Blue Sky? Not that I am aware of, but I let my colleague answer.
I've not seen anything either. No. Also, Sven is.
One of the OpenAPI guys is building a Blue Sky AT thing in Swift. And so
Honza.
source as well, I think. Yeah, Honza. I'm pretty sure he's got a Swift client for AT stuff. And then one point to add, I hope you can hear me over the noise. One point to add about the Lambda stuff is that my Swift cold start times are quicker than my TypeScript warm start times.
Can you repeat that? Your Swift cold start time are smaller than your TypeScript?
Yeah, so it's quicker for my Swift functions to start up from cold than it is for my TypeScript functions that have already been run. So
yeah, that's not surprising, because with TypeScript you need to load the full Node.js runtime, and with Swift
and then interpret it, just in time to compile everything. Yeah.
Another question on DynamoDB for you, Nathan. Does DynamoDB has strongly typed queries? I think the answer is no, but I'll let you develop.
Well, they're not, but you can build your own code that tries as much as possible to lower the amount of repeating all queries and again and again. So that's one thing that I recommend doing. So for example, if you have in my talk we had the user and #sign as a prefix. So for example, if you have prefixes, I would recommend having them in constants, so you can reuse them everywhere in your code and not stringly type them everywhere. So that's one thing. I also forgot to mention in one part of my talk that you have to plan ahead the access patterns. So there's also something very important in when you start doing advanced more in DynamoDB, which are secondary indexes. You can have basically read-only tables in the same table with a different structure. So yeah, if you were interested in the subject, I don't remember who asked this. I think it was also Philip. Philip, so you can have secondary indexes, so you don't need to query. You should never query more than once. You should be able to do everything that you need in only one round trip to DynamoDB, and with that you have to plan your. By the way, secondary indexes you can add on the go, so you can add these indexes.
You don't need to recreate the table.
But again, regarding the compiled support for queries, you need to build them by yourself.
I'm switching a bit back and forth between subjects as I'm progressing in the list of comments. Sorry for that. Going backwards to the AT protocol, Tim, you suggest that Honza would have developed something, and actually Honza is listening to this meetup right now. He just commented in the thread as well that yes, he's working on some side project, weekend code, but there is something there. But yes, you can generate a Blue Sky client from their OpenAPI doc using the Swift OpenAPI generator. And the custom Swift line feeds on Blue Sky are implemented that way. That's the message from Honza. Thank you, Honza, for commenting on this part. Someone asked for the link to join the Slack. I post that in the comment as well. So if you are not on the Swift open source Slack, you can join. There is a lot of discussion, a lot of channels there. And one more question from Steven. saying that Apple showcased the distributed actors in 2022 and 23. Has there been any discussion about continuing that work? Maybe for you, Tim?
I'm not aware of anything. I mean, the distributed actors are being used and work in terms of like real world demos that are kind of open source and out there. I haven't seen anything recently.
Okay. There was a demo at FOSDEM. FOSDEM is an open source conference that happened in February in Brussels. I'm searching the link as we talk. But someone showed distributed actors during a demo during that conference.
Yeah, Jadiel, who's also in the chat, or at least was earlier, gave a talk about that.
And here is the link to the entire Swift track, and you can get to the video from there.
Mm-hmm.
And Glenn says there was a presentation in 2019, maybe titled "Swift on the Server." Are we there yet? It would be great to see a similar presentation in the near future with the help of the advocacy team of Swift on the Server. Say like a state of the union where we are now. See, it was one of the presentation from FOSDEM as well, Glenn. If you look at the link to the presentation from FOSDEM, there was the welcome from Paris Pittman, which is the open source program manager at Apple, that present the Swift ecosystem and Swift on the server. Looks like there is no more question, and that was great. We had a lot of.
Thank you all for joining, having this wonderful meetup together.
And thank you to our speaker, Nathan and Andrew, for your presentation, your code, your live coding. It was really great. All of that will stay forever on the internet. I will post the link to the video on the Slack and the forum, so you can share with your colleagues as well, or watch a part that was a bit too fast or a part that you missed. We are making a lot more view after the meetup than during the live. Thank you, everybody. Have a good day, good afternoon, good night, wherever you are on this planet.
Bye-bye. Thank you so much.
Bye-bye.
Bye.